Okay, we are going to talk about quantitative content analysis. So even though sometimes people will use the term content analysis to mean other types of analysis, in its strictest definition, content analysis means it's going to be quantitative. Here's the module outline if you want to pause and write this down for your notes. So content analysis is systematically summarizing and describing the content of something, and that something's called a text, with a goal to compare, assess, and examine that text. Here is a formal definition from Riffey et al. It's the systematic and replicable examination of symbols of communication assigned valid numeric values and the analysis of relationships with statistics to describe and infer. And so let's take this apart a little bit. What do they mean? When they mean systematic, we've talked about systematic in this class before, about how science needs to be systematic, that this is the identification of key terms and concepts and being very specific about what you mean by relationships between concepts, and also potentially generating testable hypotheses, although there certainly are examples of content analyses that don't have hypotheses and they're more applied. Replicable, we've learned before in this class, means that others can understand exactly how it was done, especially with operationalization. Symbols of communication means messages or content that has meaning within it. The numeric value means it has to be represented in numbers. And then describing and inferring means not just what happened, but trying to infer why and how it happened. So the goal of content analysis is usually to be able to generalize or to draw generalizations about this body of text that you're examining, and then presenting those generalizations in numerical form. So for example, I did this analysis and a certain percentage of Donald Trump's tweets contain a reference to Ted Cruz or Hillary Clinton. Or the number of violent acts in this TV show is positively correlated with the length of the show. Or the relative frequency and themes in Hillary Clinton's speeches changed after a particular point in the campaign, and here's a proportion of different themes in the speeches before and after. So you're trying to, from the body of text that you're analyzing, generalize about what is true about the text that you're speaking of. So there's a couple different things that you can do in content analysis. One is just describing communication or media content. So for example, this could be a study that tries to describe the content of news coverage of an earthquake. They would select a sample of news articles from a variety of media outlets and then code the articles for different characteristics like tone, framing, the sources cited, and then the study would analyze the frequency of different tone about this earthquake to draw a quantitative conclusion. Another type is comparing media content against other content or in a different context. So for example, you could have a study that tried to look at representation of Asian Americans in news coverage versus entertainment media. The researchers would get a sample of news articles and television shows or films that feature Asian Americans and then code for them in terms of roles, stereotypes, level of diversity within the group, the tone of the coverage, etc., and then quantitatively compare the two. You can also potentially assess the portrayal of certain groups in the media. So you could look about women in political news coverage quantitatively. You can also test hypotheses of message characteristics. So for example, you could test the hypothesis that negative political ads are more effective than positive political ads. There could be quantitative content analysis in that. So a researcher could select a sample of political advertisements with positive or negative messages and then code them for different characteristics like tone, emotional appeals, the level of attack on the opponent, etc. So there's a number of different content analysis designs that we see. So I'm going to go through them here. This is not in the book, so make sure as you're taking notes that you're really focusing on these from the lecture. The first is a quasi-case study. This tends to look at just a single source or issue to try to characterize this source. It almost always is a census of the entire text. So for example, every episode of Modern Family. It's not trying to generalize to other situations, and it might look at change over time. So for example, how is the character Gloria's accent portrayed on Modern Family in the earlier seasons versus the later seasons or something. So this is sort of a case study, a quasi case study, because it is just looking at sort of one thing. A comparative case study, on the other hand, would look at a few different sources that have a particular difference. So it could be, we're going to look at coverage of this earthquake in English and French. Or we're going to look at cable TV versus public TV. It also is usually a census of all the text. So it would be, all the episodes of this show from this time period to this time period. Again, doesn't care much about generalizing, and might also look at changes over time, but generally is going to compare between two things. Like, the coverage in French had a different tone than the coverage in English or something. Or the coverage from big newspapers was different from small newspapers. Cross-sectional, from learning about surveys, cross-sectional content analysis studies will look at a number of different sources, often during a particular time or on a particular issue. Like they would look at a number of different women's magazines about body image. There's usually multi-stage sampling involved, that these usually aren't doing a census of the entire text. Generalizability is key. The goal of this would be able to say, well, women's magazines in the 70s talked about body image in this way. And it often will involve comparison. Not always, but often will. There's also over time big N studies. These are studies that look at a lot of different sources, but really focusing on change over time. There's almost always going to be multi-stage sampling, but focusing on different times. So for example, you're going to sample teenage boy magazines from the 1950s, 1960s, 1970s, and 1980s to try to see how they're covering a particular topic over time. You're trying to generalize about that particular magazine in that particular time, and is definitely going to compare between two or more time points. And then a quasi-experimental study involves hypothesis testing, which will look at how one or more factors influences the content. You're generally going to do a before and after, like how was patriotism discussed in Boy Scout magazines before and after September 11th, for example. Generalizability is key. You're trying to argue about how it was before and after, and you're going to be comparing between two different time points. So here are some content analysis study examples just to throw out there. So let's say you wanted to do a study of news coverage of political campaigns, and you could look at news articles about political campaigns and understand the frequency of mentions of each candidate or a different issue, and you would compare the results in media coverage and how it might be influencing public opinion. Like, this candidate was talked about so much more, no wonder they're increasing in getting votes. You could also do a study on advertising on social media. You could look at, types of messages in social media ads. Was it emotional? Did it involve humor, etc.? And then analyze the frequency of different types of ads. You could look at a study of gender portrayals in kids or adult programming. Any of these kind of things are examples of content analysis studies. So how do you actually do a content analysis? Well, you need to start with a rationale and a literature review, just like you would any other study. Most will have a research question, and some, as we've mentioned, will have hypotheses. Importantly, you have to have a conceptualization. These are dictionary type definitions of variables that you're going to examine in the study. So if you're looking for, discussions of body image in women's magazines, you have to be really precise about what you mean by body image. The operationalization, that conceptual definition needs to be in a precise, specific ways to measure the variables so that any of the people that are working on this project knows, yep, that is a portrayal of violence, that is discussion of body issues. You also need to determine the unit of analysis. I'm going to talk about that more in a minute. You need to write the code book. This is like a training manual for coders and has detailed instructions for how each variable is going to exist in the study. There is an example of this in your textbook that is really helpful to look through. Sampling, which we're going to talk about how sampling works in content analysis. And then you're going to train coders. We're going to talk about coding in a minute, but you need, in quantitative content analysis, you usually have at least 2 coders, and you do some initial pilot testing for intercoder reliability, which is the content analysis reliability test. And then you do a formal intercoder reliability test on all your data, you analyze your data, and you report on it. So let me take you through a couple of these important steps. So, determining the unit of analysis. This is what media and what element are you going to study. This is what data is going to be analyzed, that your findings are going to report on. So this is the unit of analysis that makes most sense for what you're trying to code. So this could be TV commercials, magazine ads, Instagram post, but also you can have more than one unit of analysis. You could have an Instagram post and the comments. So this is the actual media type that you're analyzing. Kids cartoons, advertisements in teenage girl magazines, commercials, political ads, newspaper columns. What is the actual media you're looking at? So, sampling is super challenging in content analysis, unfortunately, and it is often a matter of how you get access to the content. And unfortunately, nowadays, it's way harder than it used to be. So, in the past, a long time ago, there was only 3 TV stations. So it was really easy to create a sampling target. Remember, that's like the list of all the kids shows, for example. There were 3 TV stations, so there were probably 20 children's shows. And if you were going to do an analysis of kids shows, you would set up some recording devices and you would record all the kids shows. It was work, but it wasn't that hard. Or let's say that in the 1980s, there were 5 magazines for teenage boys. Okay, you go to the library, you get them all, you look at them, you're done. So now with streaming, cable, and the internet, it's basically impossible to really come up with a sampling frame and a target sample. So you can do other things, like you can rely on the most popular shows or something, but it isn't as complete. Another challenge with digital and social media content is time frame is very complicated. If you were saying, okay, these were teenage boy magazines in the 1970s, you can presume the magazine came out, kids read it, and that was it. Maybe they read it a month later, 2 months later, but that was it. Now, a YouTube video might have been made 10 years ago or something, and kids are still watching it today. And if you're trying to understand about kids, the effect that a certain kind of content has on kids, the time frame is totally off. You can't just look at content that was created in the year 2021 or something to understand what kids in 2021 are watching. So this is really hard. So to resolve this nowadays, people are often using what is called a composite sample, sometimes called a constructed sample. And this is sort of a variation on random sampling techniques. It is pretty popularly used, and you're trying to use the circulation or programming patterns of media content as the logic to guide sampling. And you'll see some of these examples, like we took the 25 most popular shows on Netflix or something. So it is tough, and old school content analysis people are kind of grumpy about this, but this is just the reality of today.
Okay, so let's talk about a composite, also known as a constructed sample in content analysis. So we've learned that in content analysis, it is super duper hard to come up with a sample, especially when you're sampling like a large amount of media content, like all TV shows or all newspapers or whatever. So, and especially if there's like a lot of shows on. And so a composite sample, also known as a constructed sample, is a sample that they're trying their best to get at a representative sample, but they're not actually using probability sampling methods to do it. but they're doing their best to capture the diversity of content that's on, kids' TV or something across a period of time, or a particular newspaper or whatever. They're like, okay, as long as we record on every other day for a month in the summer, a month in the winter, and a month in the fall, we're probably good. And why can they do this? Well, media content traditionally depended on factors such as day of the week, time of the week, season of the year. That's how TV used to work. Like TV that's on at night is different than TV that's on during the day. News coverage can change, right? If there's like a major event, if there's an election or something, there's a lot of different news coverage than there would be on some random day. And so we really got to do a good job of trying to account for these variations. So how do you do this? I will admit that this is not my forte. So this is just what I understand from doing it. I've actually never done a composite sample myself. But so you define your population, like what are you studying? Ads that are on the Disney Channel or late night talk shows or whatever it is. And you decide the time frame. Are you studying like a month, a year, multiple years? And you're going to select the source, okay, I'm going to study these late night talk shows, Jimmy Kimmel and John Oliver or whatever. And then you kind of create your sampling frame that you kind of decide okay, what am I going to be selecting from? And then you select a random, so there's some randomization in here, random number of units from each time period. So you might do the first Monday, the second Tuesday, the third Wednesday of the month for a whole year. And then you're going to do those analyses. So it isn't perfect, we know, but people generally agree, as long as you did a pretty decent job, you're probably capturing a decent representative sample if your goal is to reduce the bias. But it's super labor intensive and it might not work. And obviously, as we've talked about before in this class, the way that TV works now, it doesn't always work with the way that people view TV right now, or Instagram or anything like that, right? So this can be really, really tough. But it is sort of what people just have to do. So let me share my screen. I'm just going to show you all a couple examples really quick. This is the example from our textbook that they talked about. They talked about a study from Dana Mastro and someone I don't know who did a television program over a week. So they did 1 week composite of, current prime type TV across 9 broadcast and cable networks with the most viewers, 10 weeks, only scripted and reality TV shows. They skipped special events like award shows. They had a list of all programs during the regular season. 1 episode of within the population was randomly sampled, etc. So that's an example. And then I found one. This was a study about queer representation on TV, and this said that GLAAD, which is a nonprofit that's the gay and lesbian, actually I don't know, I forgot what the actual acronym is. This always goes by GLAAD. Oh, they don't have it listed here. Anyway, so this organization puts a report about TV shows that they, not in a scientific way, but they all said have gay characters. And so the researchers were like, okay, well, we're going to use that list, even though we know it is possibly imperfect. But they said, basically it's better than anything else. And then they screened 2 randomly selected episodes from each non-animated series. And then they looked at particular references in it. So again, not uncommon. It's sort of just what we got to work with when we're doing content analysis, because sampling is so, so very tough. But it's okay. People do it and it works. And nobody is as long as they made a good effort, people feel pretty comfortable about it. So it's totally okay to do.
So in terms of the sample size, rule of thumb sort of guidance is at least 100 cases of anything that you're looking at. So if you're looking at 1970s teenage girl advertisements, you got to have at least 100 of them. And you need a rich range on the variables of interest. You can also use a confidence interval to calculate sample size too, but that can be really hard if you don't know your entire population. And of course, as always, the cost of doing it, the time, and the amount of error you're willing to tolerate factor into decisions about sample size. Okay, so you've gathered all your teenage boy magazines or whatever. What do you do next? Coding. This is the key, and we're going to talk about this as well when we talk about qualitative research. This is the media content itself, but it can be in any form of communication content. Coding is categorization into distinct categories. It's applying definitions of concepts to the text or messages to document the features of those texts or messages. I like to say it's sort of like giving something a hashtag. So let's say I go get a manicure, I post it on Instagram, and I'm like, hashtag manicure, hashtag nails. By adding that, I am adding a descriptor to document the features of that photo of my manicure. And hypothetically, someone could click on that hashtag and pull up hyperlinked all the pictures that were hashtag manicure or hashtag nails. A code is like a hashtag in that way. So imagine that you're looking at these teenage girl advertisements from the 1970s. You're like, hashtag body image, hashtag exercise, hashtag boyfriend, because you take the content in that ad and you're adding these codes onto it. I will mention though that it's not just adding these labels. There's 4 different codes or ways that you can do codes, and these are important. First, just like a hashtag, is the variable present or absent in the content? Is there hashtag body image or not? But you can also code the degree to which a variable is present or absent. So for example, if you're thinking about like that there is discussion of going to a school dance. Is it a lot in an article or is it just a little bit? And you have to agree with everybody else that's coding what it means to have a lot or a little. You also could just do a count, the number of times a variable is present, and this is called counts or frequencies. So maybe in an article you count the number of times the body image is mentioned. And then you can also have description of content that's later categorized into larger categories. So it could be like, this picture is of a polar bear that is floating on a iceberg out in the water. And then later on, you're going to categorize that as animal. So this is coding, very important. But your codes need to be both valid and reliable. Coding is valid if the codes are accurate in reflecting the meaning of the concept that they're actually trying to capture, right? So if you're coding something with body image, it really does need to match that conceptual definition that you had. You also have to code variables in a way that's reliable, that you're applying that coding definition the exact same way across the different content, and that everybody else that's doing the coding is also doing it in the exact same way. You're trying to, in this way, balance the richness of the coding with also trying to get your different coders to agree with each other. And this is the key. Getting your coders to be on the same page and agreeing with each other is a really hard thing. When I was in graduate school, I was a coder on a project that was looking at violence on TV. And so I would have to like watch an episode of a cartoon and I would have to count the number of times that violence happened. But then there'd be somebody else that would be sitting in that room at a different time than me that would be counting too. And maybe I counted 8 things of violence in that cartoon and the other person counted 6. Your goal in content analysis is to get those people to agree, because the definition of what a violent act is in that cartoon is so entirely clear. So how we do this is a thing called intercoder reliability. Sometimes it's called inter-rater reliability too, because you're rating something, but coder, rater, same idea. This is how we determine reliability in content analysis. So the general rule is at least 10% of the total sample needs to be coded by multiple coders and go through a statistical intercoder reliability test. You want to randomly select that selection, probably, because that's the most accurate. And there should be enough variance so that the entire coding scheme can be applied. and coders always should be working independently from each other. So there is a calculation that's done for each variable that shows what percentage of the time the different coders agreed with each other. The bare minimum that's done is a percent agreement, and I'm going to show an example of that in a minute. Another very popular form of intercoder reliability is called Krippendorff's alpha, and this is this guy, Klaus Krippendorff. He actually died recently. He was a communications scholar who was big into content analysis, and he determined this particular calculation for how much coders were agreeing with each other. There are other calculations that can be done. I won't go through the list of them, but it all depends on kind of level of measurement and what you're trying to do. So when you're computing this intercoder reliability statistics, you want to make sure you compute it for every variable, not just an overall average for all the variables. And that you make clear the sample size that you collected to calculate this intercoder reliability. In general, we recommend that the coders are not authors of the study so that the coders aren't aware of the hypotheses or the literature review that was done. You want to be able to hand the coders a code book, a guide. Remember, that's the manual that the coders are going to use. And they should be able to do this coding without anyone having to explain to them how things work, which is very, very, very hard. Whenever I teach this to graduate students, they think that this is going to be really easy, and then they have the hardest time doing this. So what happens if you can't get good intercoder reliability? Well, there might be an issue with the coding. You might have to adjust your coding scheme or your code book, or you might need to reduce the number of categories you're using. There also might be an issue with the coders, and you need to do more training with them. So here's an example of percentage agreement. So imagine that, this was there violence in the show? Yes or no? Allison said yes, Nick said no, Martin said no. So if I look at Allison versus Nick, they didn't agree. Allison versus Martin, they didn't agree. Nick and Martin, they did agree. So when I add this up, it's 33.3% repeating pairwise. That means against each of each other. Percent agreement. That is not so good. And so you would be doing training. There are some rules of thumb for this percentage agreement. They say that 70% agreement or better is okay for exploratory studies. 80% agreement is all right, but most people say 90% agreement or don't do it. I guess if it was a super complicated new thing, but yeah, 90% is sort of what we like to go from. So, content analysis positives. This is great because it's non-obtrusive research. You're looking at things without having to talk to people or ask or intrude in people's lives. You don't need to get IRB approval for the most part, so that's cool. It can be fast. You also can look in the past and do these overtime comparisons, which is really neat. It's also much easier to do comparative work, to compare against cultures or different languages. You can also look at questions that humans might not be able to articulate themselves, like racism in the media, bias, etc. So there are some really good things about content analysis. I would also add that content analysis can be a great place to start for a project, but you probably are going to want to do more than just analyzing content if you're really trying to get deeper at bigger questions. So there are a number of challenges to content analysis. A lot of people consider it very simplistic because you're kind of just doing these counts. Also, there's a lot of emphasis on comparative frequency. So comparative frequency is the counting of the number of times that specific words or phrases or particular topics appear in a text. And even though these can be really interesting, a lot of people would say that this oversimplifies complex messages and overlooks nuance and context. So, for example, if you do a content analysis of a political speech and you're just looking at the frequency of keywords, you might be missing like the rhetorical strategy or tone because that's not part of your analysis. Also, the problems or topics that people look at in content analysis are chosen because they can be quantified. It's not necessarily because they're really important to society. Another slightly annoying thing is that people use this term content analysis to mean a lot of things that are not technically content analysis. So you'll see qualitative content analysis uses a term that should be called thematic analysis probably. So that's just a little annoying when you're searching around for things. Another challenge is this idea of manifest versus latent constructs. We've talked about this before. In content analysis, we're often relying on manifest variables to represent latent concepts. So for example, just because the word body image was in an article, we're representing an idea that is much more than just a word. So this can lead to inaccurate or incomplete conclusions because we're not acknowledging the complexity of a latent concept. Also, manifest content is really surface level. So for example, whether or not presidential candidates are wearing suits in a campaign ad versus like wearing jeans and a t-shirt or something. Like some people might say like, who cares? Who cares? Latent content involves variables that require really deeper thought to code. And so this is hard for coders to do. So for example, it's pretty easy to say to a coder, is that person wearing a suit or not? It's harder to ask a coder to determine if the clothing a candidate is wearing is gender stereotypical, because that requires some thinking. But if latent content variables are logically come from observable content and they're really well described in the coding scheme or code book, they can be reliably coded by multiple coders. Another challenge that we've discussed already is this data access, and now there's this additional ethical challenge with social media data. So there's this constant debate about data being public, right? Data on Twitter is public, data on Instagram is public, right? But a lot of people would argue that intention matters. That person that put out that tweet or that Instagram post didn't intend for researchers to use that content in a research study. People have a sense of who their audience is on social media. Like, for example, their 20 Twitter followers, and even though they know in the back of their mind that anybody could go and see that content at any time, they're not thinking about that. So some people, including myself, believe that it is really a challenge to use social media data. Further, people can't really consent to having their social media post analyzed by researchers. I guess you could theoretically reach out to that person and DM them and say, can I use this in a study? But people are just not doing that. Another issue that you may or may not be aware of is that some researchers can buy large data sets while others can't. So for example, somebody collected all the tweets during a particular election or a protest. Or they took all the data from Grindr or Tinder, and they bought it because they had a lot of money. And then they can do analyses on that. Not every researcher has access to that data, and so it ends up creating a situation where people with access to these special large data sets, either because they have the money or because they have, a friend that works at Snapchat that will give them access to this data. Others can't look at it to see about replicating it, and that research ends up being so cool that it makes research that isn't so cool look really bad. So this is a problem. Also, there's a big question. When you have this much data, how do you deal with it? And one thing that is growing in popularity is automated content analysis that is used with a computer. Sometimes this is supervised and sometimes it's unsupervised. So supervised automated content analysis is when training data is pre-labeled to train a machine learning algorithm to identify patterns or features in new unlabeled data. So the algorithm is supervised by the labeled data to learn how to identify specific categories or attributes in the text. So for example, Let's say the training data has pictures of cats and dogs and cows and horses and ducks. The algorithm knows what those things are already, so when it encounters something new, this is again a supervised data, it knows, okay, it has pointy ears, it has whiskers, it's a cat. So different examples of supervised content analysis include machine learning, sentiment analysis, and topic modeling. Unsupervised automated content analysis doesn't rely on existing training data. Instead, it uses computational methods like clustering or latent semantic analysis to identify patterns or themes in the data without any prior knowledge. This unsupervised is often used in new data sets or exploratory research where they're trying to look in to find patterns that wouldn't be seen before. I also want to mention that with the supervised data, that what goes in is what comes out. So for example, if the training data was racist, then the output is going to be racist too. You may have heard this before in talking about training algorithms. So this is a new world. We're still learning about it. And a lot of scholars mix human and automated coding together. It's pretty rare to see a really good content analysis study that is all automated just yet. But we will see. The time is coming. The algorithms are getting smarter. So probably in the next 10 or 15 years, a lot of this will be different. But I imagine that human coders are not going to go away anytime soon.